So implementation considerations are summarized on the next slide, and here we basically say that in this design of this object that we're trying to design a singleton, if instance of the class does not exist, the new instance is created. It's happening right here, but only if the previous instance does not exist. If an instance already exists, the singleton simply returns a reference to that object. So of course it happens right here. Singleton constructor must be protected or private. Okay, so that's the constructor of the singleton that we have right here. The singleton pattern must be carefully constructed using multi-threaded applications, and that's what we have with our attempts to maintain synchronization using this mutex, which is in reality this is Java util concurrent locks reentrant lock, which is a very popular synchronization object. So because of this sort of like critical section that we create, which is protected from concurrent execution, if two threads of execution attempt to say get instance, the creation method at the same time, we check whether the instance already exists, and we only permit one thread of execution concurrently to run just exclusively to execute this parts of the code protected by our lock between the creation of the lock and its release. So the second example that I have in our set of handouts is this handout right here, which is called Abstract Factory in Singleton. So here we have the ElevatorBank, which is implemented as a singleton. As we discussed earlier, we would like to possibly provide access to the ElevatorBank to all of the objects in the system without the need to create its copy, because we really may not need a second copy of this object in the entire application. So this is an example of this class, and I'll just close prior files. And so this is the ElevatorBank. Okay, so its design is that it actually here we try to portray the this design right here that the ElevatorBank also uses the elevator factory. So basically to create copies of the elevators, because right here in this in the system we have two types of the actual elevators, the freight elevator and the passenger elevator, and so they both implement the elevator interface. So this is the elevator interface. Accept floor request is what's being put in this interface. And so there is a freight elevator right here, and there's a passenger elevator, and of course they both implement accept floor request because they both implement this iElevator interface. So we can add this to our design. We can add this interface and name it. Name this interface iElevator, okay, and have our interface implementation by the elevator. And this elevator actually is let's say that this is let's just resize and rearrange this just to make everything consistent with what we have here. So we just design this idea that we have the passenger elevator. Okay, so I'll just rename this elevator passenger elevator. Okay, and we also can copy and paste this. And the second type of elevator, we have the freight elevator, which is very similar. Okay, so we just adjust this name right here, and this of course also implements this interface. And I suspect that now we need to be able to let me see. So so right here both of these elevator types in the system have let me just resize this a little bit like this. So both of them have access to visitors, but I think that our elevator bank will be associated with the interface, right? So we probably are going to do it like this. So we're going to keep our interface here, and now we will bring back our aggregation, actually the other way around, like this. Okay, so the elevator bank will be aggregated with an interface, and now the interface will be exclusively used by the elevator bank to maintain all of the interaction with elevators. And so this is our second elevator type, and it also has a collection of visitors which are its riders, right? So elevator can have our visitors as riders, both passenger and I think elevator freight may also have to do the same thing, because apparently passengers can also enter freight elevator. Okay, so this is the idea right here. And so what else we have in this design? We also have the factory. Okay, so we have the factory, which is implementing create elevator method, and here the concrete. So this is abstract factory, of course, and we have the two concrete factories for the freight elevator and another one for the passenger elevator. So we have all of these right here. Okay, so we can indicate that we have this iElevator factory interface. Like this, and we have two of these, the passenger factory. Okay, so another class which is factory of passenger elevators, and another class that is the factory for freight elevators. Okay, so this is the design. Of course, we need to say that both of these implement this interface. Okay, so we can arrange this. Okay, so that's the factories. And basically they have create elevator method right here. So we can add this operation create elevator, which of course is an abstract operation. Now, as far as I remember, right here, if we go back to the elevator bank maintains a reference to the elevator factory. So that we also need to provide as association. So here is an association that the elevator bank has a reference to this interface. Of course, we need to keep everything readable and keep arranging our classes so that we need to make sure that our class diagrams as readable as possible, like this. Okay, so that's the possibility. Okay, so this is the design of the class diagram for what we have so far in terms of this example. What else do we have here? So basically we have two interfaces, iElevator and iElevator factory, which implements the example of the abstract factory for elevators. We have two concrete factories. We have two concrete elevators that we discussed already. We have the elevator bank, which is implemented as a singleton, and because it's implemented as a singleton, it makes possible that all other classes in the system have access to its instance simply by going to get instance, right? So here's the get instance, which should be quite recognizable already. The same approach, begin critical section, which means acquire lock. If our singleton reference is still null, then we create new elevator bank. So elevator bank is protecting its own creation. Right here, elevator bank constructor is empty. It doesn't do anything because our initialization happens right at the level of the data attributes right here, but we keep it private, which is important so that we can guarantee that only within this specific class we can make this new elevator bank. And so that's the idea, and the rest of its operations is to set the elevator factory, and then we can call create elevators to basically go to the factory and manufacture a number of elevators, which of course are added to the collection of the elevators, which is array list of, again, this is where this aggregation becomes implemented, right? So this array list of references to the iElevator interface is right here. So this is this. Okay, so this association, then an idea of aggregation is right here. And of course we also have a client program right here, main app. Okay, so this main app, what it demonstrates is that we construct the factory for passenger elevators. Okay, and then we just need to make sure that at this stage, all we need to do is just make sure that we configure our elevator bank, and we just say, okay, let's set this factory of the passenger elevators right here, and now we communicate with elevator bank through the name of the class and get instance, which, by the way, of course, is a static method. So inside the elevator bank, the singleton reference is static, and of course get instance operation is also static. So it does not require creation of elevator bank object in order to be invoked. Instead, we use the name of the class to call the static operation. And so the rest of the system will be talking to this object, the only instance in the entire application, the only copy protected by the singleton design. It will be achieved by basically the entire application will just basically accessing its functionality through elevator bank get instance, elevator bank get instance. So later on we change the factory to something different, which is freight elevator, and we now create also elevators, and apparently we create only one elevator right here. So create elevators here. What it does is just basically says, okay, you give me the range of elevator IDs, and it just basically uses character identifiers and constructs these elevators using the current factory, which is this reference to here. Right, so this call create elevator is delegated to the concrete factory. First, the passenger elevators are made up, and then this here, this is the freight elevator factory. So that's the class design. So we can now save this diagram. All right, so save as and save it in this demo abstract factory singleton, and I'll just use the same name. All right, so I'm just going to save this. So now we have saved this diagram, and so this is your example. And so what's left here is just to take a look at the sequence diagram and what happens in this application at runtime. So we already have a script for the sequence diagram. So this is the script right here. Okay, so this you can see what's happening in the script, but I'll just show you a final result, which is this picture right here. And so you can see that we start in main and we set factory passenger first, get instance, the same interaction with ElevatorBank being the singleton, acquiring the lock, creating the first instance, returning it back, then we set elevator factory again we get instance, and this time we don't create it. And we call create elevators, and the first time we construct the passenger elevators, and then we basically demonstrate that here we also create the freight elevator as well. So this is both the combination of abstract factory design pattern combined with the singleton design of the ElevatorBank. So this is your sequence diagram of what is happening inside this method main. When you try to run it, pretty much the sequence of all method calls should be right here in this sequence diagram.